Hello everyone, today let's discuss a A-level mechanics paper. So many people ask me to explain mechanic papers. One thing you need to know, any past exam papers only give you a sense of the difficulties, levels and skills. You will be tested, but never one single question you worked in the from the past exam paper will appear again. So more importantly, you need to know the problem solving skills, how to approach the solve a question, what kind of knowledge you need to master, etc. Those are more important. So I hope I make myself clear. Now let's start with this question. Uh, this figure shows a particle P of mass 0.5 kilograms at rest on a rough horizontal plane. So there are some very important or interesting information that you should know. That is actually the rough horizontal plane. That means what? That means there is friction force. Okay, so question A, you need to find the magnitude of the normal reaction of the plane on P. So we know the normal reaction will be perpendicular to the contacting surface, that is upwards, because it will need to balance out the gravity force, which is mg. So because in this vertical direction only two forces exist, they are the weight and the normal reaction. They must be the same, because otherwise this ball will move up and down for one direction. But the fact is, it's rest. That means the resultant force along the vertical direction will be zero. So N equals mg. And since m is half kilo, that is 0.5 g. So that is the first question, the magnitude of normal reaction. And how about second one? We know the friction coefficient is 2/7 of the surface. It's 2/7. Now a horizontal force of a magnitude x Newton is applied to P, to the particle. Given that P is now in limiting equilibrium, you need to find the value of x. So again, draw a diagram, although it won't give you any marks, but it will help you to analyze the problem. So we know this P rests in rest and also in the limiting equilibrium, and also by the effect of a force acting on it. Either this direction or other direction doesn't matter, because your friction force will be in the opposite direction. So X is the horizontal force, and here will be the friction force to the opposite direction, and they must equal to each other in order to have a limiting equilibrium on the surface. So one thing you need to know is the friction force is not always a fixed value, because if that is the case, the ball will move under the circumstances that the x is less than friction force. The friction force is always try to balancing out the moving force until its limit, which is normal reaction times the friction coefficient, which is 7/7. So we know that normal reaction is 0.5 g times 2/7. And 0.5 g is half g times 2/7. That we know the friction force is actually 1/7 g. So that is our friction force, Newton, of course, Newton. And then that is our friction force. And that friction force is in the equilibrium, limiting equilibrium, to the maximum value, which is 1/7 g, when our horizontal force X equals to the friction force. So the answer to the second part of this question will be 1/7 G. If you use a calculator, want to calculate the value to decimal number and taking G is 9.8 meter per second square, then you will have 1.4 Newton. Okay, 1.4 is one accepting answer, and 1/7 G also okay, correct. But either way, you will have the full mark of this question. So this is the easier question for the mechanics, A-level mechanics, checking your basic understanding of the resultant force along horizontal and vertical directions and the relation between the normal reaction and the friction force. So I hope you understand the solution. Enjoy the video. I see you in the next for more of mechanics. Bye.